believe finally that you are able to see me and hear me. This course is entitled Basic Electrical Circuits. Welcome to the course. I am Nagendra Krishnapura from the Department of Electrical Engineering at IIT Madras. What we will do in this course is to learn about ways of analyzing circuits. Okay, so it's not about any particular circuit or any particular gadget, but a general technique or general techniques for analyzing any circuits, which you can expand to any new circuit that you may come across. Okay. As I mentioned earlier, please feel free to interrupt the lecture by raising your hand, and I'll also try to be systematic and give you time, let's say every few minutes, every 10 minutes or so that we can have all the doubts clear. Okay. Here is a presentation that sort of outlines what we will be seeing in this course. Okay. In fact, it turns out that in this semester, I'm also teaching a course at IIT Madras entitled Electrical and Magnetic Circuits. What I'll be talking about in this online course will be only the electrical circuits part of it. Okay. Now, what are electrical circuits? Electrical circuits are interconnections of electrical components, and basically every electronic or electrical gadget that you see forms an electrical circuit. Okay. And magnetic circuits, just as a point of information, are interconnections of magnetic components, and I think all of you would be familiar with transformers and motors. They form magnetic circuits. Now, in this online course, our focus will be on electrical circuits, and they are absolutely everywhere around us. You will be able to see electrical circuits. You are probably using so many electrical circuits in your day-to-day life. Okay. So just as an example, the laptop on which I am making this presentation, your mobile phone, music player, the headphones that I am wearing, all of these things form electrical circuits. Okay. In this picture, you can see an example of a mobile phone which is opened up, and it has a number of complicated circuits inside. You build up the circuits hierarchically from simple elements to more complex circuits, and they are put together to make the bigger circuit and so on. So finally, you end up with a very large circuit. Okay. Is this volume okay? Okay, I believe the volume was a bit low, and now it is fine. As I was saying, a mobile phone is a circuit, as is your music player and so on. And here I have shown a very large, physically very large circuit on the left side. It is a transformer that is used to bring power to your homes, and that is also a circuit. And on the right side is another transformer. The one on the left side is probably as big or even bigger than this room in which I am sitting, and the one on the right side is a couple of millimeters. They are both transformers. Okay. The main point I want to drive home is that circuits themselves come in all shapes and sizes, but there are some methods of analysis that are applicable to all circuits, and that is what we will be discussing in this course. So as I said, this course is about analysis techniques applicable to all circuits, and it's not about any particular circuit. And it turns out that if you look at electrical engineering curriculum in any university, this turns out to be one of the most important courses. Okay, mainly because it lays a foundation for a number of courses that you will encounter in your electrical engineering curriculum, such as networks and systems, where you will analyze circuits using more advanced techniques such as Laplace transforms. And some of you may go on to do courses in analog circuits. The things that you learn in this course, the methods of circuit analysis, are absolutely essential for that course. And also, some of you may be studying in detail electrical machines. Again, the analysis methods learned in this course will be useful for that. And it turns out that also, if you want to get a job in electrical engineering, in a lot of electrical engineering companies, the interviews will start with some basic electrical circuit questions. Okay, so it is by and large a very useful course for your further studies as well as your career and so on. Okay. Now, what are the topics that we will go through. First, we will have a discussion on electrical quantities and elements. Some of you would be already familiar with this. Okay, I think all of you will have some notion of what a voltage is, what a current is, what a resistor is, and so on. And also, you would have studied both in high school and later some basics of electrostatics and electromagnetics. Okay, and the things that we deal with, voltages and currents, are related to what we study in electromagnetics, such as fields and charges. Okay, but we will not deal with, we will not go down to the level of fields and charges, but we will stay with voltages and currents. So, in the initial part of this course, I will also tell you how these things are related to each other. Okay. Then, after we discuss electrical quantities and elements, we will see how to analyze circuits. Again, at some level, for very simple circuits, you would be familiar with this, but we will see how to scale it up for large circuits, which could be arbitrarily large. Okay. Now, it turns out that there are also certain theorems, certain general theorems about circuits, which are very useful in analyzing circuits, in representing circuits, and so on. We will discuss those things. Then we will talk about what are known as 1 and 2 port networks. It will be very clear what I mean later. Okay, one port means you have one set of terminals where you can apply a voltage or apply a current. Two ports means there are two such pairs of terminals where you can do the same, and so on. Okay, and there are ways of transforming between multiple ways of representing these circuits. We will also study those things. Okay. Now, one of the other interesting things that we'll study is the op-amp, not in great detail, but as an ideal op-amp, it forms a basic network element, and from that you can make a number of interesting circuits. In fact, some of you who may have had building circuits as a hobby would have already done this, would have already used op-amps. What we will do in this course is to lay a proper foundation for that, and then if you want to design new op-amp circuits, how to go about doing that, and how to analyze complicated op-amp circuits, those things we will deal with. Okay. Now, it turns out that essentially circuit analysis consists of, you look at the circuit, based on the circuit you come up with a number of equations, and then you solve the equations. Okay. Now, if your circuit has only resistors, then you will end up with a set of algebraic equations, and you have to solve that. I think you already know how to do that. It turns out that you can also make interesting circuits when you have capacitors and inductors. In those cases, you will end up with what are known as differential equations, and some of you may know how to solve it. What we will do is go through the treatment of differential equations, the particular kind of differential equations, that is, constant coefficient linear differential equations that we will use in this course. We will deal with that in some detail, so that you are familiar with the kind of solutions that can be present. Okay. Now, finally, we will look at polyphase circuits. At least some of you would be familiar with three-phase power transmission and so on. So, we will look at some of those things and see why those things are important and see how to analyze those circuits. Okay. Now, in this online version of the course, we will not be dealing with magnetic circuits, but you can look at other resources to get some knowledge about those things. Okay. Now, as far as the goals of this course are concerned, it's very simple. You learn circuit analysis and learn how to do it well. Okay, and the way to do it well is to practice problem solving. Now, you practice problem solving for many different reasons. Sometimes you do it for competitive exams where you solve the same kind of problem many times. So the next time the same type of problem comes up, you don't have to think about it. Now, here it's a little different. Okay. The reason for practicing solving a lot of problems is to be confident enough of solving any other problem. It may be of the same type, it may be of a slightly modified type, or even a completely different type. Okay. Any problem that you have to solve, you have to be able to approach it with confidence and then solve it. So that's why you have to solve a number of different types of problems. Okay. And also, more importantly, when you solve any problem, you have to understand every step of problem solving. Okay, it's not a test of speed, but you have to know why you are doing what you are doing. So, whenever you solve any problem, please make it a habit to understand every step and then move on to the next step. Okay. And a sort of secondary goal is to learn about linearity. What I mean by this will become clear, but a large number of circuits that we will analyze will turn out to be linear. What it means is that you apply a certain stimulus, you will get some response. You apply another stimulus, you will get a different response. And you combine the two stimuli, the response turns out to be the combination of the original responses. Okay. Now this simplifies analysis a great deal. It turns out that you don't have to analyze the same circuit many times. You analyze it for one set of inputs. You will know the answer for many other sets of inputs. Okay, in fact, any other set of inputs. So you have to become comfortable with this, the implications of linearity, how to recognize linearity and exploit it while analyzing circuits. Okay. Now here are some resources that you can use. First of all, as I think was already mentioned to you, these lectures, these online sessions will be recorded and they will be made available to you. In addition to that, you can make note of a URL that I will give you. In our group, we record our lectures and you can view those lectures. And one of the courses that we have taught is this electrical and magnetic circuits, which has some overlap with the course that I am teaching now, but is at a quicker pace. So you can view those lectures. You of course are familiar with NPTEL. I think that's how you came to this course. So NPTEL lectures are also very useful on specific topics. And the VLSI group homepage at IIT Madras, this is also something that you can use to further your knowledge of circuits. Okay. So with that background, perhaps we can get started. I'm going to share the journal now. Okay, I mentioned some resources. I'm going to write down the URLs here. This has recorded lectures on various circuits related courses, and you can also see okay. And finally, of course, all of you know about NPTEL. Okay.